Let's explore evaluating logarithmic expressions. Let's write down some pretty remarkable properties of logarithms. First, let's recall how to think about a logarithm. What is the exponent I must raise a to equal m? That's exactly what the log base a of m is. The exponent you raise a to equal m. That's our first rule. So in these rules, a represents a positive number not equal to 1, m and n are positive, and r and x are any real numbers. Second property, the log base a of 1, the exponent we raise a to equal 1 is 0. How about the log base a of a? What do I raise a to equal a? That's 1. How about the log of the product of two real numbers? Well, the log of that product will be the sum of the logs of the factors. Let's prove this. Let's see why this must hold. The exponent that makes this true is the log base a of m times n. Here we have the log base a of m that makes it true, and here we have the log base a of n. So m is equal to a to the log base a of m, and n is equal to a to the log base a of n. So a product of exponentials with the same base is that base to the sum of the exponents, as we saw. So what we have here is two equal powers of a. A to this exponent equals a to this other exponent. Since exponential functions are 1 to 1, we know that the exponents must be equal. Which is exactly what we were trying to prove. The next rule. If we were to do the log of m over n, that's equal to the log of m, the log of the numerator, minus the log of the denominator n. In all these, you'll see that the base is always the same in all of these rules. The next rule. The log of a power, m to the r. This is equal to r times the log of m. And finally, a to any real number x is always equal to e to the exponent x times the natural log of a. Let's evaluate this expression without using a calculator. So what we have here is a difference of logs with the same base. Arguments are positive, so that rule about a difference of logs applies here, and we have it equal to the log of the quotient, 16 over 2, which of course is the log base 8 of 16 over 2 equals 8, log base 8 of 8. And the rule the log base A of A, the rule said that that was equal to 1. So the original expression evaluates to 1. How about this expression? Let's evaluate it. So let's remind ourselves what the natural log is. By definition, it is the log base E. So we have the log of a power, and the rule for that was the log of a power, m to the r, equals r times the log of m. And the log base E of E, by this rule over here, that is equal to 1. So the original expression evaluates to the square root of 2.